Hello students, you're welcome to biology class, and today we continue our class on the past question and solution 2018. Now we have question 30. Now this is an aquarium, and this aquarium is said to be airtight. Okay, so it said the most important factor needed by the organism is, and the organism here is the fish. As we know, the organism in an aquarium is the fish. So the first one is the light energy. You have the low humidity, and C, oxygen, and G, nitrate. If I may ask you, there is a factor that is also important in the water, and that factor is called the oxygen. And that is why the water used to have a dissolved oxygen. So the aquarium is also a part of the aquatic habitat where the fish that lives inside the aquarium needs the oxygen to breathe. And that is why most times in an aquarium used to have the air pump being created or being modeled into the aquarium. Therefore, the answer here is oxygen, because the aquatic habitat is also in need of dissolved oxygen. Now, number 31. Which of the following instruments is used to determine the turbidity of water? So the first question is, what is turbidity? In your normal biology, we say turbidity is the muddiness in water, how muddy the water is. And you know, when the water is muddy, then the particles are merged inside that particular water. And the muddiness of water is determined by the penetration of light inside the water. Okay, when the light is able to penetrate in water well, therefore the muddiness of the water is low. So what do we use to measure the turbidity of water? So we have hygrometer. Hygrometer is used to measure the density of water, how dense the water is. The hygrometer, grow. Okay, anything grow means up. So it's used to measure what is up, which is the moisture, the water in the atmosphere. Then hydro, anything hydro means water. Therefore, the hygrometer is used to measure the density in water. Now let's go to the Secchi disc. You can see that out of all these options, the one that is a little bit thicker in the mouth, turbid in the mouth, is Secchi disc. Therefore, the Secchi disc is used to measure the thickness or the muddiness in water. What about the rain gauge? Rain gauge is used to measure the amount of rainfall. So the answer here is the Secchi disc. Now let's go to the next question. That's number 32. Now, in ecosystem, the least efficient energy transfer link is from the dash. A, secondary consumers to decomposers, sun to producers, C, primary consumers to secondary consumers, and D, producers to primary consumers. Now, this question is talking about the energy transfer, and we have what is called the law of thermodynamics. The first law of thermodynamics says that no transfer of energy from one form to another is 100% efficient. That is, what are we saying? We know that the primary producer, or we say the producer, is always down. Okay, let me work this out as a pyramid of energy. Okay, so we have the producer here, the producers. So after the producers, what do we have? We have the primary consumer. Okay, the primary consumer. Then after the primary consumer, we have the secondary consumer, and after the secondary consumer, we have what is called the composers. Okay, the producers, the consumers, primary consumer, secondary consumer. We can also have the tertiary consumer. However, so let's stay on the secondary consumer, because here in my options I have what is called the secondary consumers. So we have the producers. What is the producer in the ecosystem? The producer in the ecosystem is the green plant. So we say the green plant. What is that particular organism that can eat up the green plants? For example, we have the grasshopper. So the number of grasshopper here will be lesser than the number of green plant. That's why we have the bar is reducing up. Then what can consume the grasshopper? We have, let's say the toad, for example. Let's say the toad. So the toad here can also be consumed by decomposers, since we have decomposers as part of our option. So I will note that the number of decomposers in ecosystems should be more than the number of toad, grasshopper, or green plants. So I can have it here is an odd-shaped pyramid of number. So we have decomposers like the bacteria. So let me have the bacteria here. Let me have the bacteria here. So where is our source of energy? The sunlight is our source of energy. And when you are transferring energy from the sunlight, let's say 20,000 kilojoule. So it's going to reduce when it gets to the green plants. Okay, the green plant is going to have, let's say, 19,000 kilojoule of energy. Okay, then from the green plants to grasshopper, we have like, let's say 10,000. Then from grasshopper to toad, we have 5,000. And when it gets to bacteria, we have about 400. It is telling us that as we are moving from one feeding level, which is called the trophic level. This is the trophic level, feeding level, the energy is being reduced. And that says that no transfer of energy from one form to another is what? Is 100% efficient. If I may ask you, how is the energy lost here? Energy is lost as what? As heat. Okay? So, let's look at the answer. Secondary consumers to decomposers. Yes, these are primary producer, primary consumer, secondary consumer to decomposer. So the answer is from secondary consumers to what? The composer, the least efficient energy transfer. That is, the energy has been reduced totally from 20,000 to what? To 400 between the secondary consumer and the bacteria, which is the composer. So the answer is the secondary consumers to decomposers. Now, xerophytes have the characteristics aimed at consuming water, except, now let's look at how the xerophytes are able to conserve water. Xerophytes are plants that live in the deserts. Okay? So how do they conserve water? They conserve water by having a thick cuticle. Cuticle is that particular outer structure that protects the outer structure that protects the epidermis. Okay, it protects the epidermis from loss of water through what is called desiccation. Desiccation, DESSCATION. So now broadleaf surfaces. The xerophytes should not have a broadleaf, because when they have broadleaf, they can lose the water. Okay, they can have something stomata, and they can also have the waxy cuticle. So the answer here is what? The broadleaf, except the broadleaf. So they don't have the broadleaf, and that is why we pick the broadleaf as our answer. So we meet in the next class. Goodbye.